A Windows command injection vulnerability, hidden in a popular developer framework, that could let attackers run arbitrary commands on your machine. That's CVE-2025-62801, a newly disclosed flaw in FastMCP, the standard framework for building MCP applications. If you've ever used FastMCP or tools that rely on it, especially on Windows, this is a story you need to hear. In this episode of Infosec, let's start with some context. FastMCP is a framework that helps developers build modular MCP applications, lightweight, scriptable components that interact with local and cloud services. It's used in all kinds of environments, from developer laptops to corporate build machines and even in CI pipelines. That means any security issue inside FastMCP can ripple across developer workflows and automated systems. Think about it like this: it's not just an app, it's part of the machinery that builds other apps. So if it's compromised, attackers could potentially hijack your development process itself. That's what makes CVE-2025-62801 so concerning. Here's what the researchers found. A component inside FastMCP, a function called generate_cursor_deep_link, takes a parameter known as server_name and embeds it directly into a custom link format. That link eventually gets processed by another function, open_deep_link. On Windows, open_deep_link calls the command shell, cmd.exe, using shell equals true. That's a big deal because when user input is passed into a shell command without strict sanitization, special characters can change how the command behaves. In other words, if an attacker can influence the server_name field, they can escape the intended command and run their own. That's what we call OS command injection, or in CWE terms, CVE-78. The vulnerable behavior existed in FastMCP versions before 2.13.0, and it specifically affects Windows hosts that run FastMCP install cursor. On Linux and macOS, this call doesn't use shell equals true, so they're not directly impacted by this specific bug. So who's at risk? Any Windows host using FastMCP before version 2.13.0, that includes developer workstations, CI runners, and shared corporate build machines. In practice, that means local developers installing or testing MCP components, or automation scripts that run FastMCP install cursor as part of a build. This isn't a remote exploit in the traditional sense. It's more of a supply chain and local execution vector. But because FastMCP is often used in automated pipelines with elevated privileges, the impact can still be severe. An attacker who can get their malicious server_name processed could execute arbitrary commands during an install. It's a reminder that build tools and frameworks can be just as vulnerable as production apps, and sometimes even more dangerous because of the privileges they run with. Let's unpack this idea of shell equals true. When a program runs a command with shell equals true, it's like handing the entire command line to the operating system's command interpreter. That means any special symbols, like ampersands, pipes, or carets, aren't treated as text. They become instructions that can chain or redirect commands. If user input gets injected into that command line, those characters can hijack the process. That's why security experts have been warning for years. Don't use shell equals true with untrusted input. It's an easy mistake to make, and it shows up in all kinds of software, from web apps to build tools. In FastMCP's case, it created a dangerous path for attackers to escape the intended command context. If you're learning something new from this breakdown, take a second to like, subscribe, and share this video. It really helps the Infosec Now channel reach more developers and security professionals who care about staying safe online. When you hit that like button, YouTube's algorithm shares this kind of cybersecurity content with more people, and that helps everyone stay a little more secure. Alright, let's get back into it. Let's imagine how this could play out in real life. A developer downloads or installs a component that contains a malicious server_name value. During installation, FastMCP processes that name and runs a shell command on Windows. Instead of just opening a local process, it executes an attacker's payload. That could mean data exfiltration, credential theft, or even lateral movement inside a corporate network. In a CI environment, it's even worse. Build agents often run with high privileges and access to code signing keys or deployment credentials. A single compromised runner could poison your build artifacts or leak secrets. This is why supply chain security is such a huge focus right now, because these kinds of bugs don't just affect end users, they affect the very tools we use to build software. So what can you do about it? First, check your FastMCP version. Anything earlier than 2.13.0 is vulnerable. Upgrade immediately. Then audit where FastMCP is being used, on developer machines, in CI pipelines, and in automated build scripts. Next, review your logs. On Windows, look for unexpected cmd.exe processes spawning during installations or builds. If you see strange command line arguments or processes that appear after FastMCP install runs, investigate immediately. And remember, this isn't just about FastMCP, it's about patterns. Anytime you see shell equals true or direct command line calls with user input, that's a red flag. Make code reviews look specifically for that. Finally, limit where untrusted metadata like server names can be introduced. Treat every input as potentially hostile, even if it looks harmless. Remediating this issue is straightforward. Update to FastMCP 2.13.0 or later. But long-term, this is a wake-up call for secure development practices. Don't run shell commands with untrusted input. Use argument lists instead of command strings. Validate all user or config supplied data, especially anything that ends up in system calls. And from a DevSecOps perspective, integrate vulnerability scanning into your pipelines. Tools like OSV scanners or dependency checkers can flag known CVEs before they become incidents. Supply chain attacks often start small with overlooked tools like this. So keep everything, not just your production code, patched and monitored. The vulnerability was responsibly disclosed and tracked under CVE-2025-62801. The official fix came in FastMCP version 2.13.0. The issue was documented in GitHub's Security Advisory GitHub5C58RQJ5G5. Credit to the maintainers for acting quickly and releasing a patch. Responsible disclosure like this helps the community fix flaws before they can be widely exploited. CVE-2025-62801 is a reminder that even developer tools can hide serious security flaws. A single unchecked input, a simple server name, can lead to full command execution if it reaches the shell. If you're using FastMCP, upgrade to version 2.13.0 right now. Then take this as a chance to strengthen your overall development security posture. Scan your tools, audit your pipelines, and make secure coding a habit, not an afterthought. Thanks for watching Infosec Now, your channel for clear, no-hype explanations of cybersecurity threats and how to defend against them. Stay safe out there.